How to implement VAR in Python. If you are curious about how to implement vector autoregression in Python, you are in the right spot. This statistical model is great for analyzing and forecasting data from multiple time series that influence each other. Let's break down the steps you need to follow to get started with this powerful technique. First, understanding the basics of vector autoregression is essential. This model captures how multiple time series relate to one another over time. Each variable is expressed as a linear function of its past values and the past values of all other variables in the system. The model order, or lag length, is important because it determines how many past observations you will consider. Next, you need to prepare your data. Start by collecting and importing your multivariate time series data. It is important to ensure that your data is stationary. This means that the statistical properties such as mean and variance remain as constant over time. You might need to difference your data one or more times to achieve this. Be sure to check the order of integration for each series to know how many differences are necessary. Also, handle any missing values and align your time indices correctly. Once your data is ready, it is time to select the lag order. You can use criteria like Okheike information criterion, Bayesian information criterion, or the Hannon-Quinn criterion to find the best lag length. This is a key step because using too few lags may overlook important dynamics, while too many can lead to overfitting. Now, let's move on to estimating the vector autoregression model in Python. Start by importing the necessary libraries. You will typically use pandas for data handling and stats model for the vector autoregression modeling. Fit the model to your stationary data using the chosen lag order. The model will estimate coefficients for each lagged variable in your system. After fitting the model, you should perform diagnostics. Check the residuals for autocorrelation and normality to validate your model assumptions. It is also wise to conduct stability tests to ensure your model is suitable for forecasting. Finally, you can use your fitted vector autoregression model to forecast future values of all variables at once. To evaluate how accurate your forecasts are, consider using metrics like mean absolute error. For practical implementation, here is a simple outline. Import libraries such as pandas, NumPy, and stats model. Load your multivariate time series dataset. If needed, difference the data to achieve stationarity. Create the model object using the vector autoregression function. Use the model to select the best lag order. Fit the model with your selected lag. Finally, forecast future values using the results from your model. By following these steps, you can effectively analyze and forecast the dynamic relationships between multiple time series variables. This method is widely applied in fields like economics and finance, where understanding interdependencies is key.